Professor Chen. This is my second video for this week. This video is about question 2. Given f(x,y) equal to this one, and y greater or equal to 1, and x located in the range between 1 divided by y to y. And the first question is draw the non-zero definition region of f(x,y). We can just apply these two conditions here to draw the non-zero definition region of f(x,y). And this is a diagram. And this line is y equal to the 1 divided by x. And this line is y equal to x. And with the condition of y greater or equal to 1 and x located in the range between 1 divided by y to y, we can find that the shaded area is a non-zero definition region of f(x,y) here. And the second question is find A so that f(x,y) is a valid joint density function. If f(x,y) is a valid joint density function, when we integral the f(x,y) from the negative infinity to the positive infinity, we will get 1. So in order to find the value of A, we just need to integral the f(x,y), which means this part, from the negative infinity to the positive infinity, and make this equation equal to 1, and then we can solve what the value of A is. So after my integration, we can find that A equal to 2 here. So when A equal to 2, so that f(x,y) is valid joint density function. And find and draw the marginal density function f(x) and f(y). With the definition of marginal density function, f(x) equal to the integration of y of f(x,y) from negative infinity to the positive infinity, and f(y) equal to the integration of x of f(x,y) from the negative infinity to the positive infinity. So we can just apply these two formula here to find what f(y,y) and what f(x,x) looks like. And first, let's calculate the f(y,y) here. So we just need to integral f(x,y) from the negative infinity to the positive infinity. But actually, the upper limit and lower limit is not the negative infinity and the positive infinity, and we need to write the upper and the lower limit of this integration in the function of y here. So the upper limit and lower limit would be 1 divided by y and y here. So we can just integral this part from the 1 divided by y to y. So we can find the f(y,y) looks like this. And f(x,x) is equal to the integration of f(x,y) from negative infinity to the positive infinity, which means we need to integral this part from negative infinity to the positive infinity, and just like what we discussed in the first part, f(y,y) here, the upper limit and lower limit we need to discuss a little bit. First, we already know that with this condition here, y equal to or greater than 1 here, we can find that the upper limit is positive infinity and the lower limit is 1. But in different range of x, this integration have a different upper limit and the lower limit here. The first circumstance is when x located in the range between the 0 to 1, the f(x,x) would be the integration from the 1 divided by x to the positive infinity here. So after we integrate this part, the f(x,x) would be 1 second. And in the in the other range of x, when x located range between the 1 to positive infinity, the f(x) has exactly different upper and lower limit. The lower limit would be x, and the upper limit would be also positive infinity. So we just need to integral f(xy) from x to positive infinity here to find what the f(x) in this range looks like. So the f(x) is this one. So we can just draw the diagram of fyy and f(x) based on its own function here. So these are their diagram. And the third question is verify that f(x) and fy are valid density function, just like what we did in the question 2. We just need to integral the f(x) and fy from negative infinity to the positive infinity to see if its value is 1 or not. So after the integration, we can find that the fyy equal to 1 is its valid density function, and also the f(x) is. And thank you, that's all.